Good evening, good morning, good afternoon, wherever you are. It's my pleasure to welcome you all to this live stream with AWS User Group Bangalore. My name is Ransi and I'm the co-organizer of AWS UGBLR and your host for the session. We also have an exciting online quiz where top three winners get $100 worth of AWS credits. So do hang around till the end of the session and it could be your lucky day. All right. So for today's session, we have Ashwin Murali, who would be presenting on the topic of AWS VPC 101. Ashwin is a DevOps practitioner and a cloud infrastructure expert. Ashwin has over a decade of experience working on public clouds with specializations on cloud migration, infrastructure monitoring, and automation. So without further ado, over to you, Ashwin, and take it away. So Ashwin, you are live.
Hi, can you hear me?
Yes.
All right, cool. So let's get started, right? So hey everyone, good morning, good afternoon, good evening, wherever you're joining in from. Um, Thanks for the introduction, Ransi. So I'm gonna spend about 45 minutes trying to go through the basics of AWS VPC, right? So it's to sort of get started. This is uh, oh yeah. So this is who I am, right? I'm an old school Linux and sysadmin engineer. I've been working with Shell and Unix for the most of my career. I've been working with AWS since they launched in India somewhere around 2007. Um, IoT is one of my specializations. So I've worked with a couple of companies which have large scale IoT installations. I run my own mail and DNS servers, and currently I work as an engineer at Verloop. So we are a chat bot based support platform, right? Um, so what are we going to look at in the next 45 minutes? We're going to look at a very quick intro of what a VPC is, what is the history, how did it come to be, uh, what are regions, what are subnets, what are availability zones, what are route tables, what are what we call NACLs, what are security groups, and in case you've seen this in action, what is VPC peering, right? So let's get started. Now, what is a VPC? So, but before we go ahead and answer that question, I also want to focus on who this talk is for, right? If you come from a networking background and you want to understand what AWS's building blocks are, this is a good talk for you. If you already have production workloads on AWS, but you want to understand what networking is, again, this is a good base for you to build up on. If you've done a bunch of production releases, you're already running your show on production, then this might be a little underwhelming for you, because what we're going to cover over the next 40 minutes or so, or 45 minutes or so, is going to be a whole lot about an introduction. We'll be grazing through a bunch of topics, but we won't really deep dive into it. My focus and what I aim to achieve out of this 1 hour is to let people understand where they need to start off from on AWS. VPC, being the networking layer of Amazon Web Services, is one of the bare bones foundations that you need to be really comfortable with when you want to become a cloud practitioner with AWS under your belt. When you're working through certifications, these are topics that are sort of part of the equation. When you're working in production in high speed environments where you've got a lot of deployments happening all over the place, you're spreading out your network, you're scaling your organization, understanding a very good understanding rather of the VPC will solve a lot of headache for you. So what is VPC? This is the answer, right? Your VPC is a data center. right? When you take away the cloud construct and when you take away the word AWS, this is what has been happening in any production environment over the years, right? People have a data center. The data center is broken down into sub networks. Each product or project in an organization is given a set of servers which are isolated in networks through what we used to call VLANs, and that's about it. So when you bring the same construct onto the public clouds on AWS, this construct is called the virtual private cloud, right? So it's a virtual network dedicated to your AWS account. It is logically isolated. It is RFC compliant. It is the overarching container for your AWS resources. It could be your EC2 instances, it could be your RDS databases, it could be your Kubernetes clusters, it could be Elastic Container Services, Fargate, whatever it is. A VPC is your overarching bucket for this. So resources talk to the internet via the VPC, right? So the medium of data transfer for your AWS resources is the VPC. It is the facilitator, right? So in point number 3, I've mentioned it is RFC compliant, meaning you've got your regular network constructs. A lot of networking knowledge that you bring from outside AWS directly applies here, right? There are IP ranges, there are subnets, there are route tables, there are access control lists, and so on and so forth, right? Now, VPC also brings its own security constructs. So a NACL or a network access control list and a security group construct. These two bring in a bunch of security features for you to prevent unauthorized network-based access into your infrastructure. Now, so before we move on, let's take a step back. Let's have a quick history lesson, right? So when AWS started, there was something called the AWS EC2 Classic. This was sort of retired sometime in 2013, 2014. So if your AWS account was created anytime after 2013, you won't see AWS Classic anymore. So what was AWS Classic? This was Amazon's version 1 of their network, right? It's flat. It was distributed across their entire AWS infrastructure. It was shared with multiple customers. Basically, that means that on any network, you could basically pick a random IP and you would actually end up hitting another customer's machine. It was discontinued with the introduction to AWS VPC. There was a huge migration process that happened over a few years, but then now EC2 Classic doesn't exist. All instances received a public address by default, which meant that if you were on AWS, your machine had a public address. That's it. DNS host names were fixed, they were enabled. You couldn't say that a machine should not be reachable. It was up to you to prevent access by your own methodologies. You had only shared hardware tenancy, meaning that you did not have bare metal hardware. You did not also have the ability to control who else was running alongside you in the virtualized construct, right? So now, if we go back to the VPC construct, it flips everything over. Everything is private. Your network is your personal network. You still have shared tenancy, but you do have dedicated hardware that you can reserve as well. And this hardware now can be asked to run only your organization's workloads that are defined in your account, right? Instances receive public and private IP addresses, but you can disable public addresses, right? The network is no longer flat. It is a much more evolved network. And in my opinion, and this is something that our colleagues, when we have discussions, we always rub on this point. In my opinion, this is one of the most advanced software defined networks that you can get your hands on, right? And the fun part, right? Apart from the actual entry point into an AWS data center, your entire network is virtual. There is almost there is almost very little, rather, a couple of physical systems that you will touch when your EC2 instances or your RDS is being accessed, right? So let's move on. The major constructs of an AWS VPC. These are the terms that you're going to be seeing very often as you go forward. You have regions, you have availability zones. Availability zones are abbreviated and used in colloquial language. They're called AZs. And you have subnets, right? So now, what is a region? A region is a physical location where a cluster of Amazon's data centers are located, right? So this basically means that, and each region has a code, right? So a region is called, for example, the Mumbai AWS region is called AP South 1. US has about 6 regions. There are totally about 23 regions worldwide, right? And these are completely isolated. They are physically separate, right? What is an availability zone? So given a region, there are logical isolations of data centers, right? A bunch of data centers together are grouped together and they are called an availability zone. The most important distinction here is when a region operates as a unit, inside a region, an availability zone is separated by what is called a risk domain. So your power, your internet, cooling, security, these factors are given out or spread across multiple vendors, multiple providers, so that when a failure occurs in the worst case scenario, it is always restricted to, at worst, an availability zone, right? A region has a minimum of 2 availability zones. Multiple regions have 3 or 4. There are some regions in the US which have up to 6. They're all interconnected by low latency redundant networks, so you really don't see uh, latency when you're going across availability zones. um, you know let's sort of go to the fun part now, right? So when you open your AWS account and you go to the VPC tab, right? So a quick update. I am not really going to uh, go through any live demos here. I've got a bunch of network diagrams and screen shares, but that would be about it. Again, this is so that I give an introduction of sorts, uh, with pointers to what you should look out for and where you can go to dig deeper. This is not a demo session by any stretch, right? So when you open your AWS console and go into the VPC tab, you will see a VPC called default, and this is the cider block that you will see, right? Now, when you change the regions on your AWS console, you will see that every region has the same cider block, and this is an RFC compliant, RFC compatible private range, right? It does not conflict with internet ranges, which is very important when you have to receive traffic or send traffic to and from the internet. An AWS VPC's IP ranges run on IPv4 by default, which means you have a 32-bit IP address by default, right? 172.31.00.16 is an IPv4. But if you want to run IPv6, AWS lets you do that as well, because we are running out of IPv4 addresses. Now, IPv6 is basically built into AWS VPC as a dual stack network. So where you use IPv4, you can also use IPv6. And the cider block says /16, which means you can have 65,535 IP addresses in a region, right? Now, let's move on, right? So given a bunch of IP addresses, how do I use them? You use them by breaking down your entire network block into what are called subnets. So given the IP address range, if we take a region called AP South 1, so I am saying that out of the /16 block, I want to use 3 blocks, each having 255 IP addresses. That is what /24 means. If you do not know what a CIDR notation is, head out to Wikipedia, CIDR blocks, and Wikipedia actually has a bunch of links in its tail which help you pick this up, because learning how to calculate a CIDR block, learning how to operate CIDR blocks is going to be very, very important and crucial when you're operating the AWS VPC, right? So now, what you see as AP South 1A, 1B, and 1C are what we spoke of as availability zones. So in each availability zone, I've got one subnet, each of them being a sub component or a subset of the parent VPC internet IP block, right? So what are the rules for an AWS subnet or a VPC subnet? It has to belong to a VPC. It is directly related to a VPC. It resides completely within the scope of an availability zone. While a VPC can encompass multiple availability zones of a region, a subnet belongs inside an AWS availability zone only. Now, resources in subnets. So what you do is you take a VPC IPv4 block, you break it down into subsets. Of those subsets, IPs get allocated as you create resources in the VPC. EC2 instances or RDS clusters or what all and whatnot. So each of these resources can either be public or private based on route tables, which we will look at in a few minutes, right? Moving on. So what do route tables do? A route table is basically a bunch of rules, right? It is to take a network packet that it sees and move it around on the network. Can it go somewhere? Can it not go somewhere? That is basically what a route table decides. Now, every VPC, when you log into your AWS account for the very, very first time, when you sign up and get in, you will already have a VPC in the region of choice, and that region will have a default route table. Right? This is associated with the VPC already. Now, the fun part of the route table is I don't need to use the default route table. I can assign different route tables to different subnets, which means that I can say some subnets can shape traffic in one way and some other subnets can shape it in another way. And this is sort of what the route table looks like. So what I'm saying here is that any network packet which has a destination IP which is the same as my VPC CIDR block can go anywhere in my network, right? So traffic for my VPC stays inside my VPC. That is what this particular route is signifying, right? Now, this is fun. I can send traffic inside different resources within my network. But then if I have to connect to the internet, now what do? I need what is called an internet gateway. An internet gateway is a network component of the VPC which handles traffic both in and out of my network. So when you have a public IP address and you send data to that IP address, you say you request a page from a web server, for example, it is going to hit the internet gateway of your account and it's going to come in. And when the machine sends back a response, it is going to go out through the internet gateway. And that is exactly what the second rule here shows. When you say 0000/0, it means any IP address that does not belong to my CIDR block. It could be any IP address, send it out, right? Yep. So let's And this is sort of how it works, right? The internet gateway has there is a internet IP block or 0000, which I'm signifying on my route table, saying any traffic not intended for my VPC can go out. Any traffic for my VPC can be routed anywhere inside the VPC. And this is basically how it's going to be connected. Now, here's the fun part. The moment you connect an internet gateway to a subnet, it signifies that the subnet is a public subnet, which means that an EC2 instance, for example, in AP South 1C, will get a public IP, right? But what do we do about the EC2 instance in AP South 1B? I want to keep the instance private, and yet I will want internet access. This could be for patching, this could be for getting updates, or this could be for making internet calls as a backend service, right? And in these scenarios, AWS gives a feature called a NAT gateway. A NAT gateway does something very important. It is a unidirectional pipe which lets traffic from inside the AWS VPC. It allows it to leave and exit to the internet and get a response back. But if you make a request to the NAT gateway, it is going to drop that packet. It is not going to allow traffic from the internet, originating from the internet, to reach a machine in the private network, right? So when you create a NAT gateway, it creates it in a public subnet, assigns it a public IP, and then says that any private instance can now reach the internet because we will create one more route table. So what I'm saying is, for AP South 1B, I can have one more route table entry, which says that the first rule says any local traffic VPC block, you can send it locally, but any internet bound traffic, you send it out through the NAT gateway. And this is a way in which you isolate resources, right? You can keep private resources away from getting a public IP and being exposed to the internet, and you can keep public resources, for example, web servers with IPs out on the public subnet, and they can be accessed by your users. Now, moving on, this is the network part of the network part of the VPC, right? But in addition to this, the VPC also lets you do something more, which is security. And when you say security, the first set of constructs that comes in is a security group, right? So a security group is what you can call as the distributed firewall for AWS's distributed firewall for your network. A security group operates at an instance level. It grants access to resources on the network, and here's the thing, right? It grants access, it does not deny access. And one of the most important things that a lot of people, at least in my experience, I've seen a lot of people get this wrong, is that AWS denies access by default. Any network or a system construct on AWS is denied by default. You have to grant it access, right? Now, here's the fun part. Moving on, a security group or a rule in a security group can be banded together by an IP. It can be banded by an IP range or a CIDR range, or it can also be a security group. For example, one of the most common EC2 constructs is autoscaling, right? Autoscaling basically means based on load, based on CPU demand, or based on memory demand, you add more capacity to your compute, and you shrink it back when the load has subsided, right? The scenario that when it works, what happens is that the machines come up on demand and they take up dynamically available IP addresses in your private or public range. So if this is the case, how do you ensure that your database gets access? Your machines get access to the database? So what you can do with security groups is you can say a machine belonging to a security group can have access to another security group, and this takes away a lot of confusion, a lot of complexity in terms of access control and security. Something else that you need to keep in mind when you write security groups is security groups are stateful. What that means is you define one rule, and that rule, when it allows traffic, it also builds a route for or permits traffic to go back the same route it came in. So you do not have to define two rules, you define just one. And if you say, for example, I want to allow a web server to be accessed from the internet, it also at the same time means that the responses from the web server can go back to the internet. All rules are evaluated before allowing traffic. This is one of the most important things, right? So you can have up to 100 rules per security group, and all the rules are evaluated, and the most apt rule for the given network packet is what is applied, right? The next thing, a security group can be created and put in limbo unless you assign it to a resource, for example an instance or a database server or a cluster, Elasticache cluster, or a Fargate container, whatever, or another security group itself, right? Unless you assign it, the security group's rules do not apply, right? And this is sort of for example a default security group. So if you look at the inbound rules, it says allow traffic from anywhere on port 80 for both IPv4 and IPv6. So here's another thing to remember. If you want to allow on, for example, TCP and UDP, they cannot be the same rule, they will be two separate rules. You have to add one rule after the other, and each of those rules is explicitly validated against the network packet that has come in before the packet is either sent forward or discarded. And the third rule that you see here, right, all traffic. So you're saying that regardless of protocol, regardless of port range, regardless of source, as long as it belongs to the same security group, let it flow, right? Now this is a security group. This is one of the most common constructs that you will use. A much lesser common construct is what are called the NACLs. Personal experience, I will say don't touch them, right? You have a default access control list that is built into the into your account when you get your VPC up and running. Just let it be. There are very few scenarios where you have to touch NACLs, and they come in at a much more advanced level. I'd say at this point, when you are talking of a 101 level of AWS VPC, you should not touch it. But nevertheless, you should know why you should not touch it. So, a security group applies at an instance or a resource level, right? A NACL applies at a subnet level. Now, rules have priority and they are evaluated in that order. A rule's priority starts from 1 and sort of goes up that number, and they are evaluated in that order. Number 3, this stateless, which basically means that if you have an allow rule for inbound traffic, you should have an allow rule for exit traffic as well. You forget that, you will see that your server is suddenly not responding. And to play with it is slightly more painful. Now, the last reason is perhaps the most important reason why I say don't touch NACLs. Whether you like it or not, the moment you make a change in your access control list, it automatically and immediately applies to all the resources in the associated subnet. Right, and this is sort of going to be a problem because you are going to immediately hit a wall. Now I am half an hour through. I've got another 10 minutes. Ransi, I have 10 minutes?
Yes.
Yeah. All right, cool. So I'm with like the last topic, and this is something that a few of you would have seen, but I feel that even at a 101 level, a topic such as VPC peering is important to understand, because the concept of peering really doesn't have a parallel in physical networks. In physical networks, you do VLAN maps and VLAN hops, but on AWS, when you connect two networks together, there is really no physical construct that exists. There is no physical hardware that is doing this patch, right? And that is the reason why you should understand this. Um, so, what is network or VPC peering? Uh, Very simply put, it is a network connection between two VPCs. It is used to share traffic or handle traffic using the private IPv4 addresses of the two VPCs. Um, it does something called a seamless handover. Uh, Basically, that means that if you have two separate networks and they peer together, as far as the resources on either network are concerned, it operates as though these two networks are actually one single network and you're just reaching out to another IP, right? One of the most important rules for VPC peering is that they need to be on, both the networks need to be on explicitly separate CIDR blocks. And the other thing is, when you create a peer network, there are scenarios where a lot of people try to combine more than one peer network. What that translates to is, if you have three peer networks, you need to explicitly pair all directions if you want a closed loop, because a peer knows only its next immediate peer, not the subsequent peer, right? And let's look at an example, right? So if I've got two VPCs, I've got a VPC A and I've got a VPC B, and as you can see, you have two separate internet blocks, right? 10.0.0.16 and 172.31.0.0.16. Uh, and in these two VPCs, I've got one machine each. I've got 10.0.0.10, which is one EC2 instance, and 172.31.0.7, which is another EC2 instance. Now, when you pair these two VPCs, what is going to happen is, each of these EC2 instances, EC2.1 and EC2.2, they can talk to each other as though they are on the same network. Now, where is this going to be useful? This is going to be useful when you want to connect a customer's network to your network, right? When you want to connect two separate AWS accounts, or when you want to completely isolate your, for example, your data storage layer, when you want to completely isolate your analytics layer, all you need to do is have a network connection. But if you're going to go through the internet, that also means that you're going to have to expose your services to the internet in some manner, right? Now, the other problem is, the other solution is, you can build a VPN tunnel, but then VPN tunnels will always have network latencies, you'll have bandwidth issues. But to solve all these problems, you just pair them together. You just have to ensure that these two networks are completely isolated and they just get connected. Job done. Um, with that, I think what I will do is, I will open the floor for questions, and I've got the slides up on speaker deck. Ransi can share the link with the audience, and I'll take questions if there are any.
Thanks, Ashwin, for that wonderful insight on a VPC introduction. We seem to have just one question, and yeah, it was more of an ask that, can you cover something on transit gateway and VPN?
Um, so, will it? I mean, so the thing with transit gateways, is it is sort of like it's sort of like a hub and spoke model, right? You have multiple networks, you've got an office network, you've got multiple AWS networks, and you want to wire them together. A transit gateway sort of acts as the central networking hub. uh, at a 101 level, this is sort of where you start with. But yes, transit gateway is a slightly more complicated network construct where you have VPN tunnels coming in on one side, you have VPC peers happening on the other, and you sort of the central network has route tables which say which cider block traffic goes where. uh, it's not the purview of a single VPC, but it is sort of used when you have multiple VPCs and multiple data centers that you want to interoperate with. Um, VPN is sort of customer VPN is sort of more or less traditionally whatever you use as OpenVPN or any other VPN appliance, right? So what you get is you get a hardware appliance with static IPs and keys which you sort of connect into your network appliance at work, and then you have route table entries which say that traffic can flow in whichever direction.
Cool. Yeah.
Does
Thanks,
that
Ashwin.
answer the question?
I believe so. The next question is, can you explain VPC flow logs?
Um, Okay, so VPC flow logs sort of give you the ability to look at network traffic flow. Where are the packets going? Are they being dropped? Constructs like that. Um, and okay, I've sort of stopped sharing.
No
Um,
problem.
and I can't. Okay. Uh, yeah. Hello. Can you hear me?
Yes, Ashwin. So you can just explain the questions. I mean, if you want, you could share it too.
So, see, okay, so the question was VPC flow logs, right? So VPC flow logs is about capturing the actual network packets and the IP traffic that's flowing through different network interfaces of various resources in your VPC, right? So this is used for analysis. So, for example, if you've heard of network packet capture using a tool like Wireshark, VPC flow log does it at the AWS VPC level.
Okay. We have one last question. And any example where a NACL can be used?
Um, so let me think about it. Let me think about it. Let me think about it. So NACLs. Okay, NACLs. How do I handle it? Give me a few moments to sort of put it together. But then, yeah, I will answer the question before we close the call.
Sure, no worries. So while you think about that, I believe we've got another question, that is, how can we connect from our own data center to the AWS VPC?
So you have customer gateway, and you've got a bunch of VPC appliances that let you connect to the you connect your data center to AWS. You've also got a fun new thing that came out recently called Outpost, where you can get an AWS rack positioned in your data center as well, and that guy takes care of the entire connectivity into AWS.
Okay, sounds good. So do you want some more time on the NACLs, or can we start with the quiz?
You start off with the quiz. I will answer the knuckles. I wanted to explain a specific example. I'm just not able to get the words right.
Sure, no problem. So I'm going to remove you from the stream and I'm going to get
Yep,
started
please.
with the quiz. All right. So hold on, folks. So I'm just going to share my screen. Yes. So hope everyone sees this and log into Kahoot.it, and that's your game pin. Sorry, folks, about that mess up. So I hope this is visible right now. So log into Kahoot.it, and that's your game pin. So make sure you enter your proper name, because only then we can have uh, reach out to you once you get back to us if you one of the winners. So join. So we got 10 players. I'm gonna wait for a minute more. Make sure you give a proper name. I see like job zero and GP and everything, because otherwise we would not have any idea that we would be able to identify you. So I guess we got 20 players right now. I'm gonna wait for 10 more seconds. All right, so let's begin. So which of the following is a central application in the AWS portfolio? Cool. So the next one. So Sunil seems to be leading. So let's see. This keeps changing. So please stay tuned for the next question. How many buckets can you create in AWS by default? Okay, so the answer is 100. So we got good answers. So next, go for the next one. So as you can see, this keeps changing. A virtual CloudFront user is called an OAI. This stands for what? So we got 10 questions. So it's fine if you are lagging behind a little. You can always catch up. All right. So we got a new leader right now. So which of the following metrics are used to support elastic load balancing? And it's done. Let's see who the winner is. It's back to Sunil. The fifth question. Which of the following feature is used for scaling of the EC2 sites? All right. Still no change in the leaderboard. What AWS service allows you to treat your infrastructure as code? This is pretty easy. All right. You got a close contender. Okay. Next up, the seventh question. Which among these are not a container orchestration service? Not. Good. Let's see if there is any change. No. Sunil is still leading. The eighth question. Which of the following database should be used for a solution that has a very high availability? All right. Let's see if there is change. Which service performs the function that when an instance is healthy, it is terminated and replaced with a new one? All right. So we have no changes in the scoreboard so far. I still wonder who job zero is. Anyway, the last question. All right. So that's the end of the quiz. Let's see who are the winners. Vivek is in third. Sunil is second. And the winner is Job Zero. I am not sure who Job Zero is. This is definitely so. Since Job Zero is a fictitious name, Sunil would be promoted to first, and Vivek would be like third. Unless and until you can prove who you are with respect to Job Zero, I cannot be able to guarantee. So all the winners do reach out to info@awsugbla.in. That is info@awsugbla.in, and we should be able to provide you with the AWS credits. All right. So info@awsugbla.in. So with that, I'm gonna stop the share and get back to Ashwin. So Ashwin, do you wanna answer your question right now?
Yeah, can you hear me?
Yes.
Right. So the question was, what are the use cases, or when would you use NACLs over security groups, right?
Yes.
Um,
Use
so
case for NACL.
Right. So a NACL can be used whenever you want a deny rule in place, right? So, for example, you want to deny traffic uh, for let's say ICMP, or you want to deny peer-to-peer traffic. You can say you can use an ACL. You want to build a software-based VPN solution, and you want to control traffic in a way that I want all traffic to go into a subnet, and I don't want the VPN traffic to sort of be spread out. Uh, you want to control traffic in both directions. These are scenarios where you use NACLs. For security groups, if you remember, I mentioned it is stateful. Basically, that means that when you send traffic in or when you allow traffic in, traffic out is automatically ensured. But in using a NACL, you can say that traffic for that particular subnet, because a NACL applies to a subnet, you can say that traffic can either be in or be out only, where you define one of the two rules. I hope that answers the question.
Sure, thanks, Ashwin. So with that, I'm going to call it a wrap. Thank you all for joining into the live stream, and hope it was very wonderful. It surely was for me, and it was a great insight on getting started with VPC if you're one of them. So it's definitely wonderful to have you, Ashwin, and for everyone who are live tuned. So we hope to be back again with another wonderful session. All right. So with that, good evening, and see you and stay safe.
Thanks for having me. Bye bye.